Let's apply our spanning tree knowledge to real-world devices. In this example, we can see ASW1, ASW2, DSW1, and DSW2. And we're just going to focus on one VLAN, and that is going to be VLAN 10. I'd like to identify the current spanning tree topology for VLAN 10. Now, there's show commands that you can utilize. For example, show spanning tree VLAN 10. That's going to identify the current designated ports, the current root ports, the current block ports, as well as whether the device is the root bridge or not. So if we go to ASW1 and type in show spanning tree for VLAN 10, you can see the information there. But let's pause for a minute. Let's not use the show commands to figure out the spanning tree topology. Let's go about it a different way based on just the topology, what we see on screen, as well as some other values that we can look at without looking at spanning tree specifically. So our goal here is to recreate this current topology. So let's do that here really quickly. So we'll throw and give us a lot of space for drawing on the screen. We'll put some lines in, just like that. We got another line there in our topology, and we are done. And we'll label them. So this is DSW1, this is DSW2, this one is ASW1, and this is ASW2. So our goal here is to figure out which of these is the root bridge, what are the root ports, what are the designated ports, and ultimately in the end, which of these ports are blocking, and it'll be specifically for VLAN 10. So as of right now, the network is using default spanning tree values. Why? Because nothing has been modified. These switches were reset. They have just the VLANs configured on them. The interface is in the correct VLANs, but spanning tree protocol is strictly 100% at its default right now. Nothing has been modified. So, first of all, we know that the default priority is 32,768. So I hope you were saying that in your head, 32,768. That is the default spanning tree priority. What is the MAC address, though, of all these devices that is going to be part of the bridge ID? Well, it's the base Ethernet MAC address that we can see in show version. So if we analyze show version and we get down to the base Ethernet MAC address, we can see that ASW1 has this particular base Ethernet MAC address. I want to take this base Ethernet MAC address now and compare it to DSW1. Because what's going to happen here is, since all the priorities are tied at 32,768, the MAC address is going to be the deciding factor of who is the root bridge. So let's just go step by step, one by one, and figure this out. So I'm going to take this MAC address, and let's go over to DSW1 and type in show version, pipe to include base. Oops, base. There we go. And if we compare it, who has the lower MAC address? Well, DSW1's MAC address is this. It starts with 28. This is 08. Well, right away we can see that 2 is greater than 0. So ASW1 has the lower MAC address. So if it was just these two switches, ASW1 would be the root bridge. So ASW1 is considered better than DSW1 for root bridge election right now. So we'll continue using ASW1's MAC address as our comparison, our baseline, because it is better than DSW1. So let's go to DSW2 now, and let's do the same thing. If we type in show version, pipe to include base, we can see that DSW2's MAC address is higher than ASW1 as well. Starts with 2, and ASW1 is 0. So right now, again, ASW1 is better than DSW1 and DSW2 in regards to the root bridge election process. It has the lower MAC address, which is being used to break the bridge ID tie that we have right now because of the priority. So lastly, let's go to ASW2 and see if ASW1 is better than ASW2. Type in show version, pipe to include base, and what do we get? Well, we get that MAC address, and we compare it to ASW1's MAC address. We see that ASW2 is 00, and ASW1 is 08. Oh, I think we have found the best MAC address between these four switches. And it happens to be ASW2's MAC address. So I am going to conclude here, based on this information, that ASW2 is our root bridge. So let's label ASW2 as our root bridge in this topology. And remember, we haven't modified any values at all. Therefore, an access layer switch is our root bridge. Not the most optimal place for the root bridge, but it is. Why? Well, ASW2 is a much older switch than the other three. And since it's an older switch than the other three, it would have a lower MAC address, because as Cisco applies MAC addresses to their switches, they look at their pool of MAC addresses and they simply grab the next one in line, and then the next one, and the next one, and the next one. And if they're in order, from an alphabetical order, or numerical order, or hexadecimal order, if you want to call it that, then it makes sense that older switches would have lower MAC addresses than newer switches. So that's really what has happened here, and that's why ASW2 is currently our root bridge.